Good morning students, myself Shraddha Agarwal from Holy Hearts Education Academy. Today I came with class 12th chapter, that is electrochemistry, and our topic is conductance as well as resistance. To study about the conductance and resistance, first we are going to deal about the topic that is material. What are the type of material? So coming to the topic, that is material can be classified into four categories. First are known to be conductors, insulators, semiconductors as well as superconductors. So conductors are those substances whose conductivity is between 10 to the power 4 to 10 to the power 7 ohm inverse meter inverse. As well as insulators are those substances whose conductivity is between 10 to the power minus 20 to 10 to the power minus 10 ohm inverse meter inverse. So as the conductivity, you can see that it is between 10 to the power minus 20 to 10 to the power minus 10. That means its conductivity is very low. As its conductivity is very low, it is going to act as an insulator. Coming to the third, that is going to be semiconductors. Conductivity of a substance is between 10 to the power minus 6 to 10 to the power 4 ohm inverse meter inverse, and semiconductors can be formed by various methods. So next topic, that is going to be superconductor. Superconductor are those substances which offer zero resistance. That means its conductivity is very high. Now, if I am going to bifurcate conductors, conductors can be classified under two headings. First is known to be metallic conductors, second is known to be electrolytic conductors. Metallic conductors are those substances whose conductivity is due to the movement of electrons, whereas electrolytic conductors are those substances whose conductivity is due to the movement of ions. This is the basic difference between metallic conductors as well as electrolytic conductor. Here the conductivity is due to the electrons, here the conductivity is due to the ions. So the first will be temperature. On increasing temperature, the metallic conductor conductivity decreases. Why? Because when you are going to increase the temperature, along with the electrons, the positive kernels also start moving, which causes hurdles at the path of the electron, and hence its conductivity decreases. Whereas coming to the topic electrolytic conductor, when we are going to increase the temperature, we can see that the electrolytic conductivity also increases, because as temperature increases, dissociation increases. As dissociation increases, number of ions increases, which increases its conductivity. Now, coming to the topic, that is factors affecting metallic conductor. The first will be nature and structure of metal, second will be number of valence electron, and third will be the temperature. These are the three factors on which the metallic conductor conductivity depends. After that, factors affecting the electrolytic conductor. So, first is the nature of electrolyte. Nature of electrolyte, that means what type of electrolyte it is. So, electrolyte can be classified under two headings. First is strong electrolyte, second is weak electrolyte. Strong electrolyte are those electrolyte which dissociates completely, whereas weak electrolyte which dissociates partially. Example of strong electrolyte, sodium hydroxide or potassium hydroxide. At the same time, example of weak electrolyte is acetic acid or hydrogen cyanides, etc. Second factor on which the electrolytic conductor depends is the greater the size of the ion, less is the conductance. That means as the size of the ions increases, its conductivity decreases. Third will be greater is the polarity, greater is the conductance. That means polarity is directly proportional to conductivity. Fourth is the higher the concentration, less is the conductivity. That means if the concentration is going to be increased, conductivity decreases. Because as concentration increases, movement of ions decreases, due to which the conductivity also decreases. And the next will be as temperature increases, conductivity also increases. This already I have explained you. Now coming to the next topic, that is the conductance of electrolytic solution. So the first is known to be resistance. Resistance is represented by the sign R, and R is directly proportional to L upon A, where R represents resistance, L is the length of the wire, whereas A is the area of cross section. If I have to remove this proportionality sign, I have to use a constant, and it comes to be R is equal to rho L upon A. This rho is known to be specific resistance or resistivity, and the unit of rho is ohm meter or ohm centimeter. Next, coming to the conductance. Conductance is the reciprocal of resistance, that is C is equal to 1 upon R. Or I can also write it down, 1 upon rho is equal to A upon L. And we know that 1 upon rho is equal to kappa, and kappa is equal to specific conductance or known to be conductivity. Hence, we can say that conductance, that is conductance is equal to kappa, that is specific conductivity multiplied by area of cross section divided by length of conductor. And unit of conductance is equal to ohm inverse, or we can write it on mho, or we can write it on Simon. Whereas unit of specific conductivity is equal to ohm inverse, meter inverse, or Simon meter inverse. L upon A is known to be cell constant, and cell constant is equal to resistance into specific conductivity. Now from this topic, numerical can be asked in your syllabus. The question is, suppose the electrical resistance of a column of 0.05 molar sodium hydroxide solution of diameter 1 centimeter and length 50 centimeter is 5.55 into 10 to the power 3 ohm. Calculate its resistivity and conductivity. So the first thing that we have to calculate the value of A. So solution, the A is equal to pi r square, and pi, the value is 3.14. R is not given to us, but diameter is given 1 centimeter, so radius come to be half. So it is half square. The value of A come to be 0.785 centimeter square. Now rho is equal to RA upon L. The value of R given to us, that is 5.55 into 10 to the power 3. Area, it come to be 0.785, whereas length of the conductor is given to us 50 centimeter divided by 50 come to be 87.135 ohm centimeter. Now we know conductivity is equal to 1 upon rho, that come to 1 upon 87.135, it come to be 0.01148 ohm inverse centimeter inverse. So student, in this topic we have learned about the conductance as well as resistance. Prepare the notes of this topic as well as solve NCERT questions. Thank you.